Hello everyone. I will discuss on spam detection with AI. My name is Sumit. I was born and grew up in India. I completed my masters from IIT Kharagpur in computer science and engineering. I did major in machine learning. After my masters, I moved to Japan. Here I'm working as a machine learning engineer at Mercari. I was always interested to learn full stack development, and that's why I'm a full stack immersive student at Chrysalis in the batch of CC23. Well, so let's start with the topic. First of all, what is a spam email? So, have you ever got this email in your inbox? Like it says that I have won a lottery of around $10 million. So, I know I'm not that lucky, and someone is trying to get my details like name, address, age, and phone number. So, if you have got any similar kind of email, then it means that you have got a spam email. So, um, spam emails can be like they might ask your bank details or your address, your personal information. So if you have got any such email, then wow, you have got a spam email. So any such emails which have a commercial purpose and you don't want them in your inbox is a spam email. Well, so once you know what is a spam email, how are we going to detect the spam emails? So first, before that, I just want to discuss what is the importance of spam email detection. So as you can see in this slide, this is the proportion of spam email traffic to the overall traffic. So you can see the half of the emails are spam, and you can see there is a little kind of uh, like decrease in this percentage after March. This might be because of COVID. So due to COVID, we started working remotely, and the percentage of actual email got little increased. So that's why we can see this trend. And also number of emails per day are going to be increased. So it is expected that by 2025, we are going to have around 376 billions of email per day. So when we say that number of emails are going to be increased, then we should also say number of spam emails are also going to be increased. Well, so with that, if the amount of emails that are being sent and we saw the percentage of spams in those is really high. So this is really important for us to have some mechanism to detect spam emails, or even for the companies who provide the spam, who provide the email service should also have some kind of automatic spam detection. So we know now that the spam email detection is really important. Then like what is actually it means? So we got a new email. We want to say whether this is a spam email or it's not a spam email. So we call ham if the email is not a spam. So basically, given a new email, we want to classify it to a spam or ham. So this is the task. Then how are we going to do that? So okay, so if someone has asked you to do that, so you have some set of emails like which we call as training data. So we have a set of emails. We want to classify them into spam and not spam. So suppose you have a data of 10 emails, 7 of them are spam and 3 of them are not spam. So you might say that okay, the probability of an email to be spam is 7 to 10, and the probability of an email to be ham is 3 to 10. So what do you think? Is it sufficient to classify a new email? Okay, so this is the data you have. Now you have a new email. So in which class do you want to classify this? Do you want to put it into the spam class, looking at the probability, and or do you want to put it on the ham class? You might think that, okay, the probability of an email to be a spam email is high. So you might think that, okay, let's put this email to the spam class. But what do you think? Is this a right approach? No, because we are not looking at the content of the email. We just have some prior knowledge about the probability of an email to be spam or ham. And whenever we are getting a new email, we are just classifying it to be a spam. Well, this is not a right thing to do, right? So this gives us an intuition that we have to look at the content of the email, what we are getting actually. So we should redefine our definition of calling something spam or not spam to be like What is the probability of an email to be spam given the list of the words in the email? So basically now we are looking at the content of the email. So mathematically we should say, okay, what is the probability of spam given the sequence of words in the content of the email? Like this. Suppose the words money, lucky draw, and one were present in the email. Then you want to find out the probability whether the email is a spam or not. This makes a lot more sense. So well, let's do some math for that. How are we going to calculate that? So we will use something called as naive-Bayes theorem. So this is a theorem where you calculate posterior probabilities given the prior probabilities. So here, like probability of A given B, A is a posterior probability. So we call A as a hypothesis. This is something we want to like get the probability. So this, in our case, this A is whether uh, email is a spam or not. So we want to find the probability of spam given B. B is an event that has already happened. So in our case, event is the occurrence of the word in the email, right? The money, lucky draw. So this is B. So what we want to find out probability of an hypothesis given the evidence. This we can calculate with the help of naive-Bayes theorem. So it basically will be equals to the likelihood probability of B given A. That means, okay, so we know if the email was an spam email, then what was the probability of words money, lucky, and draw to be present in that? And then okay, what was the overall probability a email to be spam? This we know already, right? Whenever we get a new email, without looking at the content, we can say whether what is the probability of this to be a spam or not. And then what is the probability of occurring of the words itself? This is, we call it, what is the probability of event itself? Well, this looks kind of confusing. So let's like make it simple and give you an example. So suppose we want to find whether a email is spam given the words money, lucky, and draw are present in it. Okay, so how are we going to do that? So what info we have? We have all the emails. We know some of them are spam, some of them are not. So we can get the probability of spam, which is 7 to 10. We can get the probability of ham, which is 3 to 10. This is already we know, but we can also get the probability. So we have a set of spam emails, right? So out of those spam emails, in how many emails words money, lucky, and draw were present? So we can calculate this probability easily. We can also calculate the overall probability of words money, lucky, draw to be present in any kind of email. It can be a spam email or it can be a ham email, right? So this is the probability of evidence that we were talking about. So we can obviously get this probability. So well, if we can get every probability on the right hand side of this equation, well, we get what we want, right? We can get the probability of spam given words money, lucky, and draw. This is nice. Okay, so we don't have to do all this math by ourselves. We have AI for that, which will do everything for us. We can give the data. With that, we can train the models, and it will use that training, and it will like classify new email to spam or ham. So let's try to build a simple AI filter which will detect spams. Okay, so what will be the flow for that? So this flow is common to any machine learning like algorithm. So like first you need to get the data, then you need to do some sort of visualization of the data to see how the data is looking. And then the third step is you have to do some sort of pre-processing to like remove the unnecessary data from the overall data. Then you need to do a feature engineering, like, okay, which features are necessary for you. And fifth, you need to do a training. So once you have all the features, you will go ahead and you will do a training. And then you will do the evaluation. So evaluation is like, okay, whether our model is actually good or not. Okay, nice. So let's do the first step. Let's get the data. So for spam emails detection, we have some data source available like track, enron, and genspam dataset. So you can just download any of the dataset and you can just explore that. You can just simply Google the name of these datasets. These are quite popular and you will get to know about that. Once you have the data, you will do the visualization. Like for this, visualization purpose, I have taken a subset of the emails, and you can see the in the word cloud of spam emails, words like money, free, email, business are present a lot. And these are not present in the normal emails on the right hand side. So, well, this gives us some intuition. Okay, so the words are playing an important role in the emails, right? So, well, this is just for your like visualization. Now you will do which is very important and very crucial part of any machine learning process, which is called data preprocessing. So first we will remove all the punctuation from the data. So it might have some punctuations, comma, semicolon. We will remove all those things. Then we will remove something called as stop words. So stop words are something which don't have like anything to do with the model training part, because those words are not very important. So like customer could not be better, we can just remove could not be thing from the from this email. Then we will like convert everything to the lowercase, and then we will convert everything to token. Now every word is a token. And then we will do something called as stemming. So stemming is something we are stemming the words so that they are like in their base form. And we do like many things. We do stemming, we do lemmatization, but for the time being I'm just sticking with the stemming. So we can do stemming, and so words will become shorter with that. Well, so this is all like the pre-processing part that we will do. And then we have to extract the features. So we already know that for our problem, the features are the words in the email, right? So we will use something called as bag of words model, and where we can count the word frequencies. So well, suppose we have, so how you are going to calculate the features, right? Suppose you have three emails. Okay, email 1, email 2, and email 3. So you have some words present in those emails. So this is how your feature matrix will look like. So you will extract every word from the emails, and you will make the columns for every word. And then for every email, it will look like kind of a vector of 0 and like the counts of the words. So like email 2 will be like 00100131010. So it's like every entry in this metric represents the count of the words occurring in the email. So email 2 is like money is occurring 3 times, so money has got a value 3, and rest of the things are 1 and 0. All right, so this is a one way to represent the features, but this is not a very nice way, because some words might occur a lot and they do not have a really sensible meaning, and we are giving equal importance to every word. So instead of that, we will use something called as TF-IDF frequency. So this is like now you are giving less importance to those words which are present in all the documents or in most of the documents. So this is like now you will kind of multiply the like those frequencies with the inverse of document frequencies. So you can just look at the ways to calculate that on the Google, but it's very straightforward. So now instead of like simple 0, 1, and 3 like numeric like integers, now you can see the entries are looking more of like float values, right? So but this has a lot more sense than before, because now the words does not have the pure count. They also have something like how much importance is the word, right? So this is a nice way to represent email with zeros and the numbers. Okay, so now you have all the features. You can use naive Bayes classifier, which we were talking about before. It's we want to find the probability of hypothesis given an event. Why we will call it naive? Because we are assuming that every word or every feature is independent from each other, right? We are not like making any assumptions that the words are related. Well, once the training is completed, we will do the evaluation. So for evaluation, we calculate precision and recall. Precision is something out of all the predictions, how many of them were correct. And recall is something how well we were able to predict. Like if suppose there were in total 7 spam emails and we are able to predict like 7. So that means the recall is 100%. So this is like how many of the correct spam emails we are able to predict. So these are two popular metrics to calculate the accuracy and the like performance of a model. So well, you can just use simple formulas for that, and I'm not going deep into this, but you can of course Google it, and these are very popular metrics to calculate. Again, You will not be calculating these manually. We have like libraries for this. So you will see in a demo. Okay, so let's see how everything works in a demo. So, okay, so here. So first we will, I'm using Python 3 notebook. So first you need to install some necessary packages, as the first step was to download the data. So well, I'm using Enron dataset. So you can see the dataset has total 33715 entries. That means these many emails. And this is how the email look like. And you can see that we have classes like 0 and 1. 1 is for spam and 0 is for not spam. This is like the whole data. Like I'm just exploring, okay, how is the data, the first email looks like. So this is how the first email looks like. Okay, so well, this is how we are just checking whether how many of the emails are spam and ham in our data set is kind of equal. So half of them are spam and half of them are not spam, which is a very good thing for a model to learn. As I was discussing, we need to do some pre-processing. So we will remove unnecessary characters. We will do the lower casing. We will do the tokenization. We need to remove the stop words. Well, so then after removing stop words, after doing stemming, we will get the clean data which we want for our model. So I'm calling it final data. So final data is something which has been pre-processed. Now what we will do, we will simply, okay, so for the training purpose and testing purpose, we will split the data into train and test set. So I'm using 70% of data for training and the rest of the 30% of data for testing. So, well, we will use model training. So as I was mentioning before, you don't have to do all maths by yourself. You can just simply use TF-IDF of vector library and naive-Bayes library to train the model and use the transform the vectors to TF-IDF of vectors. And you can see the accuracy of training is very good, which is 98.97, and accuracy of test is very good, which is 98.48. Very well done. With this small amount of data and with very basic model, you can see the accuracies are very good. Let's calculate precision and recall. So you can see the both precision and recall are close to 1. So if the precision and recall is close to 1, that means the model is really good. So we are able to do very good performance with the simple model. And let's try to predict. Okay, so what do you think? So let's try to make use of our model. So suppose our email was, do you want to earn money by these simple steps? What do you think? Is it a spam or not a spam? To me, it looks like a spam. Let's see what will be predicted by our model. Yeah, it's a spam. So our model says it's a spam. Okay, let's just another email. It says share your updated resume for the next round of the interview. This does not look like a spam email. Let's test it. Not spam. Very well done. So you can see, like, even with this simple machine learning model and simple feature engineering and pre-processing, we are able to get very high precision and recall, and we are able to predict the spam, like the email to be spam or not. Okay, nice. So you will find this link to this code in the link to this repo with in the description of this video. Also, I will attach the link in the last slide, so you can find out this notebook and you can explore it by yourself. Okay, let's be back to our presentation. So what are some of the drawbacks of this method? So the very first and very important drawback is that we are considering that the words are not like dependent to each other, but this is not very true. And like generally words are like related to each other. So we need to use some sort of we have to capture some sort of context of every word. So, and the other thing is that the dictionary size is very big because we are like taking out all the unique words, and then we are trying to make a big matrix. So that matrix will be very big. And other thing is that we are not considering other parts of the email, right? Sender list, CC list, and other attachment with the email, right? So we are only considering the words that are present in the email. So those parts might be important. So these are some of the drawbacks of this method. So well, with all this, let's see how the spam detection at Google works. So you have now a basic knowledge of, okay, what is a spam email? How I can write my own like spam like email detection like method in AI. But how does it work at Google with that much of a scale of emails? So well, Google use thousands of rule to filter spam emails. They use everything. They give weight to different parameters. So they have like how many attachments are there, how many people are there in the CC list. So they give like different weightage to different parameters. And they also use like complex models instead of this neo based. They use neural network based model. They also do OCR, like they also extract text from the attachment. So if you have attached some image with the email, they will also extract the text from that image, and then they will also do the same thing to check whether it's a spam or not. So they do a lot more complex work to detect spam emails, and we have seen that the Google's spam email detection works very well. Okay, so in conclusion, we can say that well, spam detection is really very important for all the companies looking at the amount of spam emails being sent every day. And AI can help to detect such spam emails. We have seen in a real demo, like with that simple model and with that less data, we were able to do very well. And we can extend this solution to other problems, like we want to detect spam reviews and we want to detect spam emails. So we can spam SMS. So we can like extend our solution to many other problems. Well, so this was all from me. Thank you so much for listening. And this is the link of the repo. You can just go and you can explore the notebook by yourself. Or if you have any questions, please feel free to reach out to me. This is my handle on Twitter, LinkedIn, and Facebook. And thank you so much for listening.